Welcome to the Group 24 presentation. For our final project, we chose to do the AI-based product recommendation system.
So now let's demo our application. So when you first open up the application, it prompts the user to enter their name for personalized product recommendations. For the first attempt, let's try Amy. So based on Amy's purchase history and similar customers' preferences, it recommends Amy these items. And then it prompts the user to end. So for another run through, let's try the name Kamal. Then based on Kamal's purchases, it recommends him these different items that he might like. Now for a third and final example, we'll try to input a name that isn't in the system and see what happens. So it tells you the customer is not found and then prompts you to click enter to end again. Now let's look over the code.
So first of all, now we start by importing essential libraries such as pandas for the data manipulation, system and OS for system operations, Scikit-learn for text processing and similarity calculations, and these are the foundational tools that we need for our data analysis.
The first function we have is the get base directory function. This function determines the base directory of the script. So basically, it tells if you are running this through a terminal or an IDE, such as VS Code, or you're running it as an executable file.
Now we have the load data function. This function reads the CSV file that was provided to us into pandas data frame. It's a really important step as our recommendations are really based on historical purchase data as provided, that the script handles the file not found errors properly and then ensures it's robust.
Now that we have the data loaded and everything set up there, let's move on to how the script processes this data for the recommendations.
So once the data is loaded, the time to pre-process it to extract meaningful insights.
So our first function that extracts those insights is the preprocess data function. It ensures that the data has the necessary columns and handles the missing columns or values and prepares data for analysis. This includes grouping the customer purchases and creating customer profiles, which are essential for understanding customer preferences.
But the heart of the script lies in the recommended products function. Here, the script uses the count vectorizers from sklearn to transform customer profiles into a matrix of token counts. Then it applies cosine similarity to find customers with similar purchasing patterns.
The script then ranks these similarities and extracts product recommendations based on their preferences. This personalized approach is powerful for enhancing customer satisfaction and loyalty.
So finally, the script ends with the main execution block. This is where it loads the data, pre-processes it, that prompts the user to enter a customer name to provide tailored product recommendations. This is user-friendly approach, which makes it really easy to deploy in a retail setting.
And now we will break down and cover some of the issues and solutions that we ran into while we were creating this project.
So the first challenge we faced was correctly loading the CVS data file. The initial code faced issues with determining the file path and handling exceptions for file not found and just overall ensuring successful data import. So the solution we implemented was introducing the get base directory file or function, which determines the base directory for the file operations. The use of this variable ensures the file path is correctly resolved, especially when the application is run in a bundle. The load data function utilizes the file path to read the CVS file into a data frame. The second challenge we faced was the code initially worked as only as a script and not as an executable, limiting the user's ability to run it as an independent program. So the solution we implemented was modifying the main execution section. The code structure was organized to facilitate standalone execution. This involves setting the file name for the CVS data, loading the data, pre-processing it, and prompting the users for their name. The third challenge we faced was the user personalization. The original code used test user for recommendations, providing a pretty generic experience. So to enhance user interaction, the system needed to prompt the users for their names, making recommendations personalized for each users. So the solution we implemented was for the system to prompt users for to enter their names. The final challenge we faced was the similarity scores calculation. The initial recommendation algorithm provided similar recommendations for all users due to the highest similarity scores across users. The challenge was to make recommendations more diverse and personalized. So to address this, the similarity score calculations was modified to lower the commonality of items, and the recommendation algorithm was adjusted to prioritize recommendations based on user preferences and purchase history, resulting in more unique and personalized suggestions.
And that has been the walkthrough of this Python script for product recommendation. It showcases the power of data analysis and machine learning in creating personalized, tailored customer experiences. Thank you for watching.